Maritime transport is of great importance for the global economy. It accounts for around 80% of worldwide trade. In fact, 90% of India's trade is done through seaports. We have 12 major ports and some 200 medium and minor ports. The advantage India has over many nations is its massive coastline, some 7,500 kilometers. We also have large rivers making inland waterways viable for transport. Augmenting India's ports through the Government of India's Sagarmala project to improve port infrastructure and connectivity is imperative as India continues its thrust to become one of the world's largest manufacturing hubs through the mission of Make in India. What is also a crucial requirement is training our sailors to navigate Indian ports and waterways under varying conditions such as nighttime, poor visibility, heavy rains and winds. For this, we have been largely dependent on our mariners going outside the country for training, a logistically difficult and expensive option. But this is now changing with indigenously developed training facilities. The National Technology Centre for Ports, Waterways and Coasts, established in IIT Madras to train sailors for complex ship navigation by using 360-degree projection simulators under varying conditions.
The main idea of this simulator is to have it as a indigenous and also a nationalized one, so that we can conduct all the training programs here in India, and there is no need for us to go overseas to carry out such type of trainings. And more importantly, all these things are developed in-house with the option to add our own simulations so that it becomes much more indigenous, which is very unique when compared to other country simulators.
In this episode, we also look at indigenous night navigation systems being developed for inland ships and vessels. Both these initiatives, which leverage technological innovations and capacity building in India, are part of the larger mission of a self-reliant India. This and lots more on our upcoming episode on Science for a Self-Reliant India, only on India Science. With this aim, a flagship project named the Sagarmala program was started by the Ministry of Shipping, Government of India in March 2015 to promote port-led development in the country by exploiting India's 7,517 kilometer long coastline. 14,500 kilometers of potentially navigable waterways which are inland and its strategic location on key international maritime trade routes. Sagarmala aims to modernize India's ports so that port-led development can be augmented and coastlines can be developed to contribute to India's growth and also to provide jobs. The project also aims at transforming the existing ports into modern world-class ports and integrate the development of the ports, the industrial clusters and the hinterland with efficient evacuation systems through road, rail, inland and coastal waterways, resulting in ports becoming the drivers of economic activity. According to research conducted under the Sagarmala program, it is expected that by 2025, cargo traffic at Indian ports will be approximately 2,500 million tons per year, while the current cargo handling capacity of Indian ports is only 1,500 million tons per year. A roadmap has been prepared for increasing the Indian port capacity to over 3,500 million tons per year by 2025 to cater to the growing traffic of both exports and imports. This includes port operational efficiency improvement, capacity expansion of existing ports, and new port developments. While these developments are helping the sector immensely, there are other challenges. Indian ports still have to address infrastructural and operational challenges before they can graduate to the next level. One such challenge was the training of sailors and crew members in navigating Indian ports and waterways under different conditions, such as nighttime, heavy rains, poor visibility, strong currents and winds. The majority of sailors and crew members were required to travel to Singapore and the United Kingdom to get trained on the ship simulators to learn the methods of navigating through these challenges in an artificial environment. Simulators are considered as the safest way for sailors and crew members to learn about the complexities of coastal navigation before they start their training on the vessel. So earlier, as there were no options, it was a very expensive and logistically difficult and time-consuming effort. To find solutions to such problems, a unique technological center, the National Technology Center for Ports, Waterways and Coasts, or the NTCPWC, was established in IIT Madras in 2018. For technological innovations and evolution of new ideas for the port and maritime sector, the NTCPWC works as the technology arm of the Ministry of Shipping, providing the needful technological support to ports and other institutions. The idea is to become more self-reliant rather than be dependent on other countries for training our personnel, or be dependent on imports for a variety of technologies and softwares. This center has now started providing effective solutions to an extensive range of problems being faced in the industry through scientific support, and also providing valuable education, applied research and technology transfer in maritime transportation at the local, regional, national as well as the international level.
The National Technology Center for Ports, Waterways and Coasts. We are part of IIT Madras and also the technology arm of Ministry of Shipping. We carry out quite a lot of simulation and modeling study for all the major ports of India as well as minor ports. We also do quite a lot of work on inland water transport. The main aim of this center is to address all the technological related solutions and issues that need to be resolved within the port sector and as well as in the waterway sector.
Scientists and engineers at the NTCPWC have commissioned a large 360-degree projection-based full-mission ship handling simulator for conducting complex navigation feasibility studies for port development projects and inland waterways. The simulator helps train sailors in navigating Indian ports and waterways under different conditions, and also helps investigate maritime accidents. A ship bridge simulator is a system that simulates ships and maritime environments for training, research and other purposes. The realism of a ship bridge simulator has a decisive impact on the value to be gained from utilizing a virtual environment for training, practicing and planning. Naval ship bridge simulators also provide training beyond standard ship handling and navigational tasks. A full bridge ship simulator has real controls of a ship bridge and seamless visuals that display ports and maritime environments. It is also used to train people in navigating different kinds of ships through various environments, such as port basins, inland ports, seaports, the deep seas and in rough weather. The ship simulator models deliver new and innovative methods of teaching ship maneuvering and port operations. It could be used to conduct studies such as navigation in open waters, coastal navigation, navigation in high traffic density situations, approaching the harbour, approaching the berth, berthing and unberthing, standard maneuvering, passage planning and execution, and collision regulations. This 360-degree projection-based full-mission ship handling simulator can be used for conducting complex navigation feasibility studies for port development projects and inland waterways. The state-of-the-art simulator can be used for conducting research and development projects at IIT Madras.
Actually, we are part of ocean engineering department, which is like 25 to 30 years of in this area. We have a very big history of studying all the ports, and we also had historical data. So one good thing is with this we can able to set up a simulation model for each of the ports. The other thing is we can able to collect data from each port, and also we can able to carry out water depth surveys, which we call it as bathymetry surveys, which we will be collecting the data, and then we can able to insert the data into this simulator. And also whatever models we had created, which can be trained or custom and tailor made for simulation studies, this can be incorporated in this as well.
The simulator installation is said to be amongst the largest simulators of its kind in the region, using the latest marine simulator technology available anywhere in the world. The system was wholly indigenously designed, developed, built and installed by ARI Simulation with headquarters in New Delhi, India. The main component of the system include an integrated bridge system with radar, navigational equipment, conning station, etc. The latest visualization systems uses a large cylindrical seamless display, vertical projection for the ship's side view, advanced bridge wing stations, integrated tug stations and a drone view with the help of 45 projectors. The simulation software provides for high accuracy hydrodynamic ship models that provide the operator with the ability to conduct complex maneuvers with propulsion, steering and interaction with the environment. With the help of this technology, various scenarios can be simulated to study the behavior of ships while entering or leaving harbors or berthing in critical conditions. Apart from training mariners, the equipment can also conduct studies on new ports and investigate accidents such as collisions and oil spills, the data of which can be fed into the simulator along with wind, ocean current information to find out how an accident occurred.
Like now technology is improving, and also we are getting vessels, more advanced vessels, and all these vessels in order to bring in, because not only it brings in economy as well, because it can be a container or it can be a bulk or it can be a cargo type of vessels which we need to bring in to the port, requires such type of expansions. So that expansion of the ports requires such simulation studies which need to be carried out for the economy thing. So by having this simulator, we can able to simulate what will be the type of ship we can able to bring in, and which is indirectly related to any cost or economy which need to be related to the port for the development.
The inception of NTCPWC is an answer to a key need and signifies a major leap in indigenous and cutting-edge technology support in the port and maritime sector, allowing increased training in a shorter time frame and resulting in overall higher quality training. The system also successfully allows naval crews to undertake a vast range of simulations without the usual associated costs, thereby drastically reducing training budgets. To empower Make in India for port, coastal and inland water transport and engineering, NTCPWC has taken a huge stride by developing state-of-the-art technologies and application products to attain self-sufficiency in providing short and long-term solutions through scientific studies and technological development.
The good part is here, it's all these things are in-house development. For example, simulation studies, the vessel models, and also the sea conditions, and all those things are done in-house. And as a part of Augmenting program, this particular simulator is actually designed and developed so that there is no much dependency on overseas. And what we have is full capacity and also fully trained manpower, and as well as the designer, the modeling team. All those things are totally set up in IIT Madras, so that they are self-reliant and self-sufficient to carry out any such studies. This is the main focus, as well as an initiative as part of Augmenting India.
India has an extensive network of inland waterways in the form of rivers, canals and backwaters. The total navigable length is about 14,500 kilometers, of which about 9,200 kilometers can be used by mechanized crafts such as boats and ferries. About 44 million tons of cargo are moved annually through these waterways. However, cargo transportation in an organized and larger scale is primarily used in the waterways of Goa, West Bengal, Assam and Kerala. To create a countrywide waterways network and to promote inland water transport in the country as an economical, environment-friendly supplementary mode of transport to rail and road, 111 inland waterways, including 5 national waterways, were declared as national waterways by the National Waterways Act 2016. Assam has approximately 1,980 kilometers of navigable waterways, of which the most important for transport purposes are the Brahmaputra and the Barak rivers. The Brahmaputra River, with a length of 891 kilometers between the Bangladesh border and Sadya in Assam, was declared National Waterway No. 2 by the Government of India in 1988. And it is the second longest waterway in the country. NW2 also has a vital role as mode of transport in northeast India, with an estimated cargo movement of 2 million tons per annum. The Brahmaputra, running through the heart of the state of Assam, provides a vital link for both urban and rural ferry services, which are the single most important transport mode for any section of the population, especially rural households in Assam. But these services are operated only in daytime between North Guwahati and South Guwahati. The ferry services get only a few hours to operate in daytime due to factors like fog and low visibility, which hampers navigation as the dusk sets in. The last ferry operates at 3 p.m., after which no navigation is possible due to darkness and lack of proper navigation arrangements. Growth in the region.
Guwahati and surrounding areas. This is the main mode of even at 4 p.m. So there won't be any transportation after 4 p.m. for them to get transferred from. Trying to resolve this through the modern and innovative technologies.
Day as well as night is not fixed. It are partly exposed ridges made of sand, gravel or silt formed by wave action are submerged or partly exposed ridges made of sand, gravel or silt formed by wave action and currents of the river. In every flood season, in finding new and alternative routes of ferries, To overcome these limitations, and IIT Madras have developed innovative day and night navigation solutions and the necessary infrastructure required for ferry Night navigation solution involves studying the migratory nature of sandshars and watering depth at different periods of the year. Numerical modeling studies are used to identify the number of islands that emerge and submerge during monsoon and non-monsoon periods and seasons. These studies help in the development of digital navigational charts with details on the depth contours with navigable routes using navigational markers to mark the water depths during different parts of the day. This information can further be transmitted directly to the boat navigation device.
This technology is purely based on developing a map using sounding technology, where we will be trying to map the water depth, different time period, so that we can able to capture in case if there is any change in water depth, can be instantly identified, and this will be forecasted to the ferries using a smart device. And also based on the integrated global positioning system, they can able to be navigated in the right path so that they won't be deviated towards a place where there are shallow depths.
An application has also been developed by the NTCPWC that can be used in boat cabins on their mobile phones and laptops based on digital navigational charts, which provides virtual aid to navigation guidance for ferry operators. The River Information Service includes a proprietary centralized command control system with functionalities for vessel traffic management, short vessel communication, weather broadcast, night navigation, communication protocols, all to enable safe and smooth operation and improve communication protocols. Innovations by the scientists and engineers at NTCPWC, IIT Madras, with the support of the Union Ministry of Shipping, Government of India, has proved to be a game changer for India's maritime sector. Despite being one of the major contributors to the economy, this sector still needed enhanced scientific interventions in spheres such as technology and skill development. With solutions like the 360-degree bridge simulator and development of night vision devices, India has started building indigenous capabilities which until now we had to depend on other countries for. Scientific solutions and innovations between the government, premier educational institutions and the private sector are providing effective solutions for technological requirements needed to strengthen the mission for a truly Atmanirbhar Bharat.